So, but how do we calculate the sample size for population mean? The same principles will apply. So we want to estimate the population mean y bar, and we'll take a sample of size n by SRSWOR to get y bar, and the y bar will be used to estimate the capital Y bar. And we stipulate that the margin of error can at most be k. So here y bar minus z half sigma y bar, this is your confidence interval, y bar plus z half sigma y bar is the 100 or 1 minus alpha times 100 confidence interval for the y bar. And and so margin of error, what's the margin of error? This is the margin of error. Z half sigma y bar is equal to k, and we know what this is for estimating the mean, so we plug this value here, s upon under root n 1 minus n upon n is equal to k, and we can simplify from this to get this value. N is equal to 1 upon n plus k upon z half s. So most of these things we know, except that we need to know this value. Without this value we cannot do this. But here is another trick. What if we don't know this, but we know that the population is normally distributed and it has a range of L? If a range is L, we would know that a majority of them, say for example 3 sigma here and 3 sigma here, will basically cover 99.97%. So then L, it becomes 6 sigma or 6s if you want it, and then S will become L upon 6. So we can also substitute this if we know the range, which is, for example, we want to calculate the average weight of a population. We can say that, okay, we don't know, but we think that the weight ranges from 20 kilos to 100 kilos, and that way we can just put this value, calculate S based on that. So let's do this. Suppose we want to study and estimate the mean weight of the population. Okay, and we will do a SRSWOR and get a sample, and then we will stipulate that the margin of error should not exceed 5% for a 95% confidence interval. And supposedly we know that the population variance for weight is 2 kilograms square, and population size n is 1000. So what sample should we use so that we can get a estimated mean weight of the population from a sample which will have a margin of error not more than 5 for a 95% confidence interval? So here we know that n is 1000, k is just 5, s, let's just say it's 4, s is equal to under root 4, that is equal to 2, and 1 minus alpha is equal to 0.95, which means that alpha half will be 1.96 based on the normal approximation. So the n has to be more than or equal to 1 upon, so we're gonna go this formula, 1 upon n, that is 1000, plus k is 5, and we're gonna put 1.96 here from this thing, and then we're going to multiply this with s, which is 2, and then this whole thing will be squared. So we will get some number which will be close to, say, 58.8. Actually, we're not going to use we will say that the margin of error it's very high for 5 with a standard deviation of 2. We're going to say margin of error is 0.5. So if we do 0.5, then you will get the somewhere around 59. So you need a sample size of 59. So then we do the study and we get a mean weight of y bar of 60 kilos. Then we'll say that our estimate for population mean is 60%. Our estimate for population mean is 60 with a margin of error of 5 and a 95% level of confidence. Level of confidence is what gives you this number here. That's what gives you this number, and rest of the thing is very much dependent on what margin of error you want this to be. When the objective is to estimate the population total, then the k becomes z half ns instead of just s. You get ns there and the root n, 1 minus n over n. So then n would be solved to 1 upon 1 over n plus k upon z half ns, and this whole thing is squared. So that is how you calculate the population total rather than just the mean population.